Okay, now. Hello, good morning. How are you? What about your weekend? Do you have time to go to the beach or not?
Hello. Yeah, I went to the beach and I got some sunburns.
Okay, nice. That's perfect. This is the Erasmus experience. It's not only go to the classroom. You have many tasks to do to integrate with the Spanish people, Spanish boys and girls. No bars is difficult probably. Um, how many people are not in Huelva? Can you you know how to put the symbol of hand up here? Yeah, people that are not in Huelva. Florian, where are you? Where are you?
I'm in Stuttgart.
Stuttgart. What place? I was
Um,
there. I was there last 2 weeks ago.
yeah. Do you know Weiblingen, Winnenden?
No, I really don't. I was in the center of the city, in the train station. There are a big museum there too. But I don't know really a lot of places there. Okay, and what's the weather in Stuttgart?
Right now it's it's raining, bad weather.
It's raining. Okay, shining. I'm not in Huelva at this moment. I'm in Jaén, in my family house, and sun is shining today. Big, super good weather here. Okay, nice. More people waiting for to enter. Okay, Florian, um, Adriana, Alexander, Benjamin, Colin, David, Elsa, Florian, Woite, Liva, Luca, Natalia, y Natalia Botsetcho. Oof, it's very difficult for me to pronounce this second name. Hello, Natalia. How are you? Natalia Savaska. Perfect. Nice. All of you was in the first lesson or not? There's someone new? No. Okay, nice, perfect. Let's go to remember a little bit what we saw last session. Let's go to try to do interactive. I'm gonna ask you questions. Try to remember what we saw last day. So, did you access to the video or not? In YouTube video? No? Do you know the link where you can find or not?
Yes,
No?
I have received the link and I opened it.
Okay. If I can write you again if you need, and I'm gonna share my screen. And I'm gonna give you this link of the channel. Sorry, because there are many videos here. There are a list for online lessons. This link. This is the Spanish. And okay, you can find here. This is the shorter. Whoops. I'm gonna give you this link in the chat. Chat. Where's chat? Okay, here you will find a list for your lesson for this year in English, okay? We're going to leave there every week. I'm going to leave there every week the lesson, the recorder of the lesson. If you need to review again or take a look. Okay. What was the concept we saw? For example, let's go to start from the beginning. We saw something about the rule, logic rule. Who can tell me what is a logic rule? Let's go to remember that. What is a logic rule? Mathematical logic rule, if you want, in mathematics.
I would say if something is true that, for a certain point, then everything in this certain area has to be true before. There you have mentioned the example with the human. If I'm a human, then my mother and my father also must be human.
Yeah, it's something like, if that is true, if whatever we call antecedent is true, then I can say the consequent will be true. So this is the idea. This is the schematic way of a logic rule. Okay, if something is true, then that means it's a row means then the consequent will be true. More in a more schematic way, something like if, for example, sun shining, then that arrow means then I will go. I will go to the beach. Okay, something like that. This is a rule. How we call at this part of the rule? What's the name we give to this part of the rule? We give a name of this part of the rule. What is the name?
Antecedent.
Exactly. This part we called antecedent, because sometimes I will use these names and I want to remember this name. And this part of the rule is called?
Consequent.
It's right here, it's a consequent. Okay, perfect. Perfect. This is the general idea about logic rule. We're going to use every time in our programs logic rules and simple facts. Simple facts, and our programs will be facts and rules. Okay, we're going to create our program with simple facts and rules. It's a mixture of two these elements. Okay, nice. What more we saw today? We saw another important concept that is called mathematical induction. Do you remember that? Mathematic induction is very, very important concept for us. Who can explain to me what that means, mathematic induction? Who can explain? What do you know about that? Complicate. Try to tell wherever you know. don't worry if not exactly precise. Give me only your idea in your brain about
Something if it's true or not.
something that is true or not. Okay, something more precise definition for that. Did you have?
When something is true, then something else is true also. Maybe.
This is that definition will be more definition of a rule, not of induction, mathematic induction.
We have a set of things, of elements, and
Yeah.
we can demonstrate then that something is true for one of these elements.
No, not for one, for all of this set, not for one. You want to demonstrate something for every element in this set.
If we can demonstrate then it is true for one, it should be also true for all the elements of the set, or not?
Yeah, more or less. Okay, more precise. Okay, you are going in good direction. This is so we have a set of elements. We want to demonstrate whatever property or whatever concept that we can apply to this set of elements, and we need what property have to be this set of elements. What do we need? We was talking about that. We need a concept of what? What we can what characteristic of this set we need to in order to apply induction to this set. We was talking about that with people in the classroom.
We need to put them in order.
Yeah, exactly. So we have a set of elements. We have a set, we can S, for example, of elements. Okay, and we want to demonstrate a property or characteristic or whatever, property P for all elements in a set S. We need the concept of order. Set S have to be sorted. Have to be a sort. Something like that. Have to be the concept of order. Okay. So you have to be to sort. What that means? If we have the concept or the concept of order in this set, we have the first one, and we have the first one, the second one, and so on. So I have to have set S. Need the concept of order inside, something like that. No, I don't know if exactly the words, but inside. Okay, so we need this set have to be sorted, or have to have the concept of order inside. Okay, perfect. So that means we will have a first element, and we call n0, and a second element that will be n1, and other n2, and so on, until whatever element. So we have the first one, the second one, I can say this is greater than this element. That is, we need this concept of order in order to apply induction. Okay, and perfect. And what is the next idea? What we have two parts in mathematic induction. What is the first part? Who can tell me? If I want to demonstrate what is the technique we use with induction.
We need two things, like the property is true for n0.
Perfect, perfect. Property P have to be true for n0, and schematically we call P0, P, the n0 is true. Okay, the property for the first one, we can call in this way with parentheses inside. That is true, perfect. And the second part, what is the second part?
It's the rule that if it's true for n-1, it's true for n.
Perfect. And it's important to notice or to remember that for n greater than n0, that is very important. The first part of the induction, we apply for the first one, but the second part we apply for n, for elements greater than the first one. So for n that are greater than the first one, we apply this rule. If the property is true for n-1, then I can affirm, I can say that the property will be true for n. So in a certain way, what we are going to do is to ask to the previous one, always. So, okay, you want to say, okay, that is true for this person. You can say, okay, that will be true if that is true for the previous one. Okay, perfect. Let's go to develop more and practice with this idea every day, because this is the main concept. It's very simple. Only these two lines you have to remember. And we are going to apply this concept in every exercise we're going to do. Okay, so we started with the concept of natural numbers, no? We started to develop this program with natural numbers. Was to create a program to say if a number is a natural number or not. Numbers, predicate. Why I call to these piece of programs predicates? What is a predicate? A predicate is something that we evaluate or ask for them, and that predicate will be true or false. Predicate is something that will be true or false. We can make questions. Okay, this predicate is true or is false, and Prolog will say if it is true or if it is false. In case of predicate will be true, Prolog at the same time will give you more information like, okay, that is true with these conditions. It's not true in general. It is true when something happened. And Prolog will tell us what will be the conditions we need, or in which condition those questions will be true. And it's important to notice that, I will try Prolog. Do you have already installed Prolog in your computers? Yeah. Everyone?
It doesn't work, for at least for me.
Why? Do you have a Macintosh or?
Yeah, MacBook Pro I have, and I have installed it, and I tried to run it, and
does-
yeah, it doesn't work.
Okay. I can help you with that because I don't have a Mac computer. I can help you with that.
Maybe there's someone else that has a Mac, and maybe for him or her it works, so he can say me what he has done.
Yeah. I don't know. I don't know how I can help you with that because I don't have a Mac. I never installed in a Mac computer, so but you have to ask to someone in internet or try to find some information in internet. Okay, you don't have the option to use another computer, no?
I have one that is 10 years old.
Okay.
But I think that won't work.
Okay. So, okay, try to do. Okay, I will try to think about an option for you. Try to give you another solution, but please, if you can try to ask in Google how to install.
Yes, I will try until next time, and yeah, maybe it works or not. I have to look.
Okay, but it's very important you have because we're going to practice every day with this Prolog to make questions. If not, it will be hard to try to learn that because I'm going to propose you some questions and you have to practice at the same time with me because it's more interesting to see by yourself what is the solution, not only be my computer, see my computer, what is the answer. Can you have your own results, okay? Okay, friends, so try to resolve next day and tell me if you are problems and we can try, I will try to help you with that, okay?
Yes, thank you.
Okay, you're welcome. Okay, perfect. So here in Prolog, we have a question mark. If you paid attention about that at the beginning, it's like a question mark because we're going to make questions every time to Prolog. We're going to ask to Prolog, okay, Prolog, that is true or that is false? And Prolog will give us the answer. And we'll say, okay, that is true when something happens, okay? And it's very important that realize that if for people that program in other programming languages, like imperative language like C or C++ or Java or Python or wherever popular language, what people do in these languages usually is to give order to the computer. Say something like, do that, execute that. This is a command, it's an order, it's something imperative that you say to the computer, do that. But here it's quite different because we are only asking questions. We ask questions and say, Prolog, that is true or that is false? And Prolog, in this way to resolve this question, will give us the solution, but only as a way to answer our questions. That is one of the main differences between imperative programming and declarative programming. It's a philosophy change in your brain. Like, okay, I'm not giving to the computer an order or a command or do that. Instead, we are going to make questions. Okay. Okay, nice. And remember that this question mark here, you have to remember as we are making questions. Nice. So what was the next we did last day? We create this natural numbers predicate using induction. Let's go to apply induction before resolve, because I don't know if we did at the end of the class very fast. Let's go to try to apply induction to resolve if number 5 is a natural number. Let's go to try to see what is the mechanism of questions to try to resolve if number 5 is a natural number using induction. Okay, let's go to take these 2 lines into account, line 21 and line 24, to try to resolve that. Okay, so the question is, number 5 is natural? This is the question. And we have to apply this idea. Okay, 5 is the first one, the first natural number or not? It's not the first one, no? So we cannot apply this rule line 21, 22. We have to apply line 24 because n, number 5, is greater than the first one. The first one in natural numbers, this number, which number is the first natural? Which number is the first natural number?
It's 1.
Number 1, perfect. So 5 is greater than number 1. So let's go to see what happened. Okay, and the rule they say, okay, 5 is greater. And this rule what tell us? They say, okay, if natural, the 4, the n-1 is true, number 5 will be true. So we have to ask what happened with the number 4. I can say, okay, if number 4 will be natural, then I can say that number 5 will be natural. Okay, this is the question. I say, okay, I have here, after this rule, what happened is we are going to ask to the n-1 element in this case. So let's go to ask to number 4. What happened with number 4? Is the first one or not? It's not the first one. Okay, so we have to apply the second rule here, and we have to ask to the number 3. Let's go to ask to the number 3. And if number 3 is natural, I can say that number 4 will be natural too. What happened with number 3? Is the first one? It's not the first one. So I have to ask to the number 2. Let's go to number 2. Is the first one? Nope, it's not the first one. So I have to, let's go to ask to the previous one. Let's go to ask to the number 1. What happened with number 1? It's the first one? Yes. And what happened? It's natural number? Yeah, because I have a part of the program, the first part that say the first number is natural, that is true. Because otherwise, if that is not true, it's not possible to obtain a solution using induction. Probably we have to use another technique. But in order to use induction, mathematic induction, I need the first one have to be true. So that is true. Yes, perfect. That is true. And what happened with number 2? If the first one is true, what happened with number 2? Is true or not? It's true because I have this rule that say, okay, I say, okay, I don't know if number 2 is true, but if the n-1 is true, here is the rule, I can say that 2 will be true. So what happened with number 2? Is true, is a natural number or not? Yes, because the rule here tell me exactly that. If the previous one is true, if the elements one is true, then the n will be true. So 2 is true. What happened with number 3? Is true or not? Is true or not? Luca, I see your head. It's nice, very good. It's true, yes. Why it is true? That is true because the previous one, because 2 is true. Because they say, okay, if the element one is true, so same happened with 4, and same happened with number 5. So what we create here with this induction is a change of questions until reach the first one. And after that, we obtain a change of answers to say, okay, if the 1 is true, the 2 is true. If 2 is true, 3 is true, and so on until reach the first one. So in that very simple way, only 2 lines of code will be necessary to resolve if whatever number is true or false. And this is the mechanism that is that induction create or this change of questions. It's always the same. We're going to create this change of question until reach the first one, and then we are going to obtain a change of answers until reach the first one. Sorry, until reach the number or the list or wherever side of the problem I want to resolve. Okay? You understood that or not?
Yes, I think it's clear.
Okay, perfect. Okay, let's go to implement. You have here the code here from last day. This is the concept of natural number. I need an explanation for this n, natural, the n. And usually we're going to write a phrase for each predicate in order to explain what this predicate, how this works, when that is true or when that is false. We need a phrase like it is true, if, whatever. Always this description of predicates will be in the same way, that is true, it is true, whatever happened. So that is true if n is a natural number, and it's false in other case. If n is not a natural number, the result of this predicate have to be false. Okay, this is the explanation. And remember, this is a comment. I don't know if I tell you last day, when I write this symbol in Prolog, it's not part of the code. That is only a comment line. It's very usual in programming languages. If you never use it, it's very common to put some explanations inside the code to understand what are you doing with your code. So you can put this symbol, and whatever you write after these symbols, the system of the compiler of the interpreter of Prolog will ignore this line. It's like it's nothing there for the program language. It's only for you. It's only an explanation for people who read this code. Okay, and this type of comments are very important to understand. Otherwise, if you don't write this type of comments, will be almost impossible sometimes, or very, very hard to understand what are happening there. Okay, so perfect. You have first rule on the induction in Prolog. This is the first part of induction. The property is true for n0. How we say the first number in Prolog is natural. Only that. We write the name of the concept I am trying to describe, in this case, the concept of natural number. We call this concept natural, then parentheses, the first one, parentheses and dot. That means in Prolog, number one is natural. That is true. And we call, in logic, we call that, this is a fact. This is a fact. This is something simple. In logic, we have two elements. We have rules and fact, something that happened. You can say, if sun is shining, I will go to the beach. This is the rule. Are two parts, antecedent and consequent. But at the same time, I can say, okay, today, sun is shining. This is a simple fact that I write in this way. Wherever is the name of the fact and a dot at the end, okay? Perfect. First part of induction. Second part, when n is greater than n0, if the property of n minus 1 is true, then the property of n will be true. This is the general schematic way to write a rule. But remember, in Prolog, we change the order. In Prolog, we write rules in this way. We change the order and we write something like that. B 2 points A. That will be logic, and this is the way to express that in Prolog. Okay, and this symbol, we will read that in a row, an arrow in the reverse direction. This arrow is from left to right, and we will read this symbol as an arrow from right to left. So this is the antecedent of the rule. I will be the antecedent, and if you prefer, I can see like this is the antecedent and that the consequent. In Prolog, we change the order. We find before the consequent of the rule and after the antecedent of the rule. Okay. Nice. So we have to express in Prolog that if natural that n minus 1 is true, then natural that n will be true. And this is the way. I'm going to start again writing that. So natural, I'm going to try to write first in a schematic way. In logic, it's something like natural, the n minus 1, then natural, the n. No, this is what I want to express. I have to translate that to Prolog, but it is idea. If natural the n minus 1 is true, then I can say the natural of n will be true. So to do that, we have to change the order. So natural n have to write before. And in Prolog, variables start with capital letter. So n in capital letter. That means that n is a variable. Otherwise, Prolog, the meaning of this n in non-capital letter is like a constant, not a variable. And here I need a variable. Okay, and now what I have to write here? Who can tell me what I have to write now? What is this thing, the next thing I have to write after write natural the n? Who can tell me?
A row from right to left.
Yeah, a row from this one. Okay, perfect. Okay, and next, what the next? I have to write here. What's the next? What's the next thing I have to write here?
Natural n minus 1.
Exactly. Natural n minus 1. But what happened here? It's not possible to do that in this way directly in Prolog because this is an arithmetic operation. And let's go to see that arithmetic in Prolog. We need to use an operator, a special operator for do that. Is operator is. Let's go to see that n. We need to do something like n2 is n minus 1. And then right here, n2. Why we have to do that? Because in Prolog, it was talking about the concept of variables. We were talking about that, no? Concept of mathematic variable and mathematic in computer science. Do you remember that? What is the difference between the mathematic variable and computer science variable? Do you remember that or not? What is the concept of variable in computer science?
So I'm going to cut the male side first, actually. Then we'll cut the female side on the wall there.
What is the concept of variable in computer science?
It's something that stores information.
Yeah, it's like a box where I put things inside. It's like a position of memory. No, this is the traditional computer science concept of variables, like in programs like imperative, like C, C++, Java, all this language, program language are the same concept. Is a variable is like a box where I put inside. It's a position of memory where I store things inside. Okay, but what is the concept, mathematical concept of variable? We was talking about that, no? It's good to remember that. I think about the theorem when you want to. I don't know if you have previous knowledge about that. Probably not. Probably not. But let's go to see. In mathematics, probably you never see that before, but it's usually when you say theorem, wherever. Say, when you have to describe a mathematical theorem, usually we use a variable. Let's say, let x a real number. Let x, for example, greater than 10, and so let x an odd number, or whatever. So in mathematics, variables, in this case x is a variable, is something that we use to describe a concept. And in each part of this description, I am adding properties or characteristics to these variables. It's something, if you want to describe, for example, a person, you can say, who have a camera? Who can switch off the camera? Let's go to try to describe a person. Who can switch on the camera for 1 second or for 1 minute? No one? Okay, Luca. Luca, let's go to describe a Luca. So I want to describe in a mathematics theorem a Luca, because it's a beautiful Italian guy, no? And I can say, okay, let Luca a human, comma. Luca is the variable. Luca is Italian, comma. What you can say more about Luca? Let's go to try to describe Luca. It's the variable Luca. What more? Sorry?
The age.
The age, okay. Luca is a man.
The
Luca
height.
is I don't know how years old, whatever.
24.
Years old, 24 years old, and so on. So you are describing the variable Luca, giving information to this variable. It's not possible to say that all the things and at the end say Luca is a horse. It doesn't make sense. It doesn't make sense that if you describe Luca, many things about Luca, the last part of the definition say, and Luca is a horse. Just, it doesn't make sense. Luca is not a horse. So this is the concept of mathematic variables, but it's very usual in computer science do something like that. X equal 1, and after that say x, and after that you can say x plus 1. That is very common in traditional programming languages, like say x, the value is whatever. Is the concept of variable is like a box where you put things inside, and I can put inside this box whatever thing. But in mathematics, this is not the concept. It's not, I cannot say Luca is a variable in Prolog. Luca is said, Luca is a man or unify with man. It's not possible in the same line after that Luca is equal to horse. It doesn't work. In mathematics, that don't make sense. And the concept of variable in Prolog are more similar to mathematics and not like the traditional way in computer science of consider or treat the variable. So in Prolog, if I try to do that, for example, Luca unify with a man, that's perfect. Luca is a man. It's not possible to say after that, Luca unify with horse. It doesn't work. But it's very common and usual in other programming languages that you can use this box to put whatever you want. And people who program in other languages, they know that it's very common to do that. X equal x plus 1. Another interesting thing in variable in Prologs is that what is the scope of variables? The scope of variables usually is where these variables inside the code of a program, probably we can have, for example, 1 page of lines of code. And the scope of variable is in which part of this code, in this long page, this variable have sense or have life, or I can access to this variable. This is the scope. And is common in, for example, in another programming languages. You have a function, for example, function f, describe this function, and here I have variable x equals 0, whatever, and the scope of this variable is the function. After this function, when this is the beginning of the function, this is the end of this function. After this function end, the x doesn't exist. The scope of this variable is only the function. We have at the same time variable to have global scope. Is variable, you can see if you define this variable, for example, var x equal 0, outside the function, the scope is the full program. This is a usually is a global variable. Okay. For people that never program, we don't need that because you never see that before. That information is only useful for people that program in other programming languages before. But in Prolog, the scope of the variable, and that is very important to understand, that start at the first of the line and finish in the dot. After this line, after the dot, a variable doesn't exist. If I write here another Luca, this is other Luca. It's not the same that I write before. It's possible to write Luca in other line. Luca is French, for example. And here said Luca unified with Italian. So that is possible if Luca is right in another line, because this Luca is totally different than the previous one. It's like another description of theorem. So when I write, if I use the same variable in different lines, variables are totally new. That is very important to understand. And this is very different in other programming languages where the scope usually is a function, is a bigger scope, a function of the whole program. But in Prolog, a scope is only the line. And from the beginning of the line until the dot. It's possible to write in several lines too. It's like a line starts here and finishes here. There are 3 lines, but the important is when the dot is marked the finished line. Okay. Any question about that? Do you have any question about scope variables? For who is something totally new, this concept of scope? Florian, you never see before the concept of a scope of variable. Okay, perfect. Who knows previously about the scope of variables? Who have previous concepts of programming and the scope of variables in other programming languages? Are you there? Are you sleeping? Are you in the beach, swimming in the beach?
Well, I told you in the first lesson that I did a bit of programming in Python. So
Okay.
this is something that I saw.
The scope, but here the scope is totally different in that you saw in other programming languages. Okay, take that into account because it's totally different. Okay, perfect. So let's continue with our natural. So for this reason, we need here Yeah, okay. For this reason, we need here a new variable, n2, and operator is. Operator is the only operator that do this arithmetic operation of this minus. We need this operator is. Okay, and n2 is n minus 1. So here, that we write here, if that is true, if that is true, that will be true. If natural the n minus 1 is true, then natural the n is true. And we express in this line. And we need also to say n are greater than 1. Why we need that? Because this rule is applied using or following the induction. We apply this rule for the values greater than the first one. We have this rule, line 7 for the first one, and this line for numbers greater than the first one. And say if n is greater than the first one, n2 is n minus 1, and that's comma in Prolog means and. All that parts or terms have to be true at the same time. That is true, and that means and, comma means and n2 is n minus 1. It's true, and natural the n2 is true. If all that is true, then that will be true. And that is finished, the code. Let's go to save that. Notice representations here, perfect. Okay, it's already open here. Let's go to close that. Perfect. Yes, it's open in other. It's not open in other. Okay, I'm going to save another name. Save natural 2. Natural 2. Okay, let's go to check if that program works in Prolog. Let's go to open Prolog here. File. To check if this program works, we have to use this file consult and load, select the representation natural 2. Here have the code. If everything is okay, we will receive a message something like that in green usually, and say no errors. Errors usually are written in red. So in this case, there are no errors. Everything is perfect. This is the time is needed to process this file or compile this file, 0.00 second. I have two clauses that mean 2 lines of codes, okay? Because the file have more lines, have 15, but I told you that Prolog ignore all the lines that start with this symbol. So at the end, Prolog say this program have only 2 lines or 2 clauses, okay? So, okay, let's go to make a questions. Let's go to make questions to Prolog. Let's go to ask, for example, okay, Prolog. Natural is number 1 natural, and say something like that. Natural 1 is true. This is my question. Hello, Prolog, how are you? What is your day? How do you feel? You feel good? Let's say, Prolog, okay, yes. What is natural of 1 is true? Prolog, how are you? How do you feel today? What do you think? Is true or not? And say, true, it's true. Natural number 1 is a natural number. Okay, perfect. Thank you, Prolog. I want to tell more things about numbers. Prolog, tell me about number 5 or number 7. Please, Prolog, can you tell me if number 7 is true? And Prolog say, oops, sorry, I make a mistake here. Okay, to write correctly the question, if the name of the concept, parentheses, wherever you have to know, in this case, number, parentheses, and dot at the end. This is the correct way to express this question. Okay, Prolog, is natural 7 true? And Prolog will say, it's true. Perfect, that's nice. What do you want to know? Give me one question. I can ask to Prolog. Give me one question. What do you want to know about numbers?
Let's see if 0 is natural.
Okay, Prolog. Natural 0. Prolog, that is true or is that true? And Prolog say, false. Very intelligent. Prolog, a clever guy. Okay, nice, Prolog. More questions. What do you want to know? Another question.
Well, could we also add calculations like 10 divided by 3 or something like that?
No, we have to write there inside the parentheses only a number, because in the description said, I can write probably here, and have to. If that is not a number, it doesn't work. I need to write their numbers. If not, it doesn't work. And have to be a number. So what more we can ask to Prolog? Tell me. For example, 3.5. 3.5 is a number? It's a real number. Or 3, Is this a natural number or not? 3.64 or 576345 is a natural number or not? Prolog say, nope, it's false. And you can ask for whatever number you want, and you will have the correct answer for whatever number you want. False. Or you can ask for negative numbers. It's false. That works with any number, whatever number. And we'll say you if that is a natural number or not. So this so simple code with only 2 lines, you can use to obtain the solution for whatever number you can imagine in the world. And Prolog can give you the right answer with only these 2 lines. So think about the powerful system, simple and powerful way to resolve things. Yeah, okay. Any question? Other people who never program think about that. I want an answer, or what do you think about that? You want to go to your home to leave this subject? Please, I want to leave that. That's horrible. What do you think? You can tell. If you think that is horrible, you can tell. Doesn't matter.
No, I think it's great because, yeah, you need it in almost every job today, or high-skilled jobs. And yeah, I think you can do many things with it, but yeah, you have to learn it.
Yeah. For everyone, not only for people who know, it's so simple, extremely simple idea of induction, and it's super powerful. It's extremely simple. With only these two lines, with the two concepts of this concept of induction, you can resolve many things. One of the example we resolve, for example, like, do you know the problem of gallons? I don't know if gallons. If you go to YouTube, I don't know if in this screen you can see the video. I will try to gallons. No problem. You know this film is called Die Hard 3 with can you see the screen or not?
Yes.
Do you remember this film or not? Die Hard. In Spanish is Jungla de Cristal, but in English is Die Hard. It's the Jack's problem. It's like have a bomb. You have to garrafa of water. You have to resolve that and put exactly one amount of water in the bigger garrafa. And if you put the correct, you save your life because you deactivate the bomb. We resolved that problem last year using Prolog. So that Prolog can save your life if you can you know how to program that. So okay, there are many things you can do with Prolog with this simple idea of induction. It's super powerful. There are many people who try to resolve this, many example videos, but we did with Prolog with this same simple idea of induction. Okay, so that can help us to do many things. Okay, let's go to make a little break of 5 minutes. What do you think? Little break to take a coffee or wherever, a tea, or take the sign.
Break is always great.
Okay, 5 minutes, I'm back again, okay? See you in 5 minutes.
Yes, see you.
Okay, see you. Hello. Hello.
Hello.
I want to translate your idea of participation because I can see your faces, not only because you don't have the camera now, and because when I write in the program, it's not possible for me because I have not the space in the screen to have all the camera. So it's not only a question that you switch on the camera or not. It's a question of I can't have all of your cameras at the same time. I write the sample. So the only way to know if you are understanding or not is your feedback. I don't want to go to advance or see many examples if you don't understand. It's not make sense for me because I know for every one of you, not only people that never program, for people that also have previous knowledge of programming, have the same that is totally new for you, for all of you, this concept. And that is very important for, to try to understand at the beginning what is the idea. Because after, we can go faster. After you understand the concept, you can go faster. But at the beginning, it's very important we establish the base of this programming, a new paradigm of programming. You understand the idea. So it doesn't matter at the beginning if I have to stop or repeat many times, because that is very important. You understood everything. So for me, it's very important. All of you, if you have any question, please ask, please. And I need this feedback, because if not, I have no, when I am at the classroom, it's very easy for me. I see your face, and sometimes I see if you understood or not, because the expression of our face tell many things when you are trying to understand whatever. And sometimes you're like, oh, what happened? We put one strange face. Probably I'll tell you, okay, I don't understand nothing. I don't need to ask you in the classroom. It's not needed. I see your face. But here I have not this feedback. So please try to answer. If I make a question, please participate, because otherwise I can go ahead, and probably after, I don't know, some days or some weeks, say, okay, that is impossible for me. I have to leave this subject and try to take another one. So I will be nice if at the end of this semester, everyone, all of the people today, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 people we have today. I wanted for that 14 people at the end of the semester, take all the knowledge of this programming concept and can resolve problem by yourself. That is the idea. So it's very important. Please don't worry. Don't think about, oh, the other people know about programming. I have no idea. I cannot ask. That is totally new for everyone. Please, I don't know how to say in English. In Spanish es tener vergüenza. Don't be afraid for asking. Please, don't worry. We're all of our friends, no? We need beer to take a beer, to go to a bar, to relax, and to ask without problem, okay?
Yes, therefore I want to mention something. For me, it's always good to have some examples to also see it. And also, if I want to watch the video again, then I can take a look at it on YouTube. And different examples help me to understand it much more easier.
Okay, we're going to do many examples in the classroom. And I am translating a document because we write a book some years ago, and I'm making the translation of this book for you, but it's not finished at this moment. So I will try to translate for every lesson the part we're going to see. Probably at the end of the semester, we will have this full part of Prolog translate. We have up to 2 parts, of one of functional programming with Haskell is another programming language. Is another programming language that is more oriented to functions and numbers. A Prolog that is more, Prolog is traditionally known as a programming language for artificial intelligence. It's a program to resolve problems related to how people resolve problems, like make this artificial intelligence. So it's probably more general, but it's very oriented with this type of problems, logic problems. You can resolve many type of problems of logic with this programming language. Okay, so nice. You want to continue or not? How do you feel? Good. You feel good?
Yes, for sure.
Okay. What the rest of the people? I want to know. I see Luca. I see Florian. I want to listen to other people.
I feel good as well, and I want to continue.
Okay. Liva, what do you think?
I'm good, thanks.
Okay. Elsa.
It's
How are you?
interesting.
You think
But
it's, oh, I want that information, please. I need that. Please don't keep inside you. Go out. Puff. It's very important to share, because we have many people here. You think that is interesting, and it probably that can help to your other classmate. Please share that. Try to make this effort of sharing your feelings. Thank you, Elsa. Thank you, Elsa, to share. Natalia. Natalia Voxiech, no sé qué. Natalia, what do you think?
Well, for me, it's okay. I can look more and learn something cool.
Okay, we are surfing. You know, that is a totally new concept. All of us are starting to surf. It's very hard task. It's not easy. If you want to start with surfing, it's not an easy task. It's very beautiful. At the same time, you can enjoy in the sea, but it's not an easy task. You have to fall down many times. So we're surfers of programming. So it's cool, it's beautiful, but it's not easy. We have to try and try and try. So David, tell me, what do you think about that?
I'm understanding the class, but I don't know. It's strange, it's new for me.
It's strange. It's new for everyone. Okay, don't worry about that. Milos Semla.
I think it's really interesting, and I want to continue for sure.
Okay, perfect, perfect. Panagiota, so.
You pronounced it really well.
Sorry?
I'm ready to continue.
Okay, nice.
Yeah,
nice.
very correctly.
Okay, super, super. That's very important, because now we are all connected. Colin Buisson. Colin.
Yeah, for me it's good too, and it's very interesting. Yeah.
Okay, so nice, yes. Perfect. Laura, did I asked you before, Laura? No.
I have a few problems with my microphone, but I already answered. But I'm having fun, and I want to continue as well.
Nice, perfect. So nice. It's important too. If someday we need to stop, but I know that this will be hard. This is the beginning. Doesn't matter if one day you say, okay, today, let's go today to finish before. That's perfect. It's enough for today. Doesn't matter for me. I have no sense to try to go ahead and fast, because this is like a building where we are now at this point. We are creating the base of the cements. What's the name in English? The base of the building. It's very important. This base are strong. You understand everything, because if now we don't understand that, after that probably the building will fall down, because that's just the base. Is for me, doesn't matter if we need now to go slowly and repeat and do more samples, because I know that after that we can go faster. Doesn't matter for me. Always happen the same way. I prefer to work this part of the subject slowly, like you have time to think, to transform your brain, because you are transforming inside your brain. You are opening your brain to new ideas, and this is very hard work for our brain. We prefer to do things things that we know before, things similar. When we try to do something totally new, it's something very hard for our brain. We need time. So for this reason, I think we are going to finish today. Okay, let's go to leave that here. I'm going to only to tell you what will be the next one things. Let's go to see. I want to leave this document for you, but I share my screen now. Oops. Okay. Can you see my screen now? Okay. Yes. This is the document I am translating for you. This is the same document I use with my Spanish student in a Spanish version, but I'm translating every day, and I have no finish the part to continue today. So do you think you have enough knowledge of Spanish using probably Google Translate? Because I use many times Google Translate. Do you think will be you have enough Spanish level? If you give you, for example, one page of this document, do you think you can translate or not?
I can't.
You can't. Okay.
I can't as well.
Okay. You don't have you don't have previous knowledge of Spanish, or very
No knowledge for Spanish. I'm just taking the Spanish A1 course right now to learn.
Okay. No worry. I can try to do is sometimes I need a lot of time to translate, but I only see. Yeah, Benjamin.
As a French or maybe for Italians, maybe it's a good idea for having both version. If we don't understand the English version, we can try to translate the Spanish one, because the languages are near and maybe we will recognize some words or something.
Okay. So for French, for Italian, will be a good idea to have the Spanish version too, no? Okay, you have the Spanish version here of the document. You have here. You can go here to my webpage. You can go here and in publications. Sometimes it doesn't here, and you can download in this link. This is declarative programming book. This is the Spanish version of the book. It's not finished the translation. So here you have the Spanish version. I can try to put here my work document with the part I translate. It's not full translate at this moment, but I can try to put here this work document with the English part, some part of the document in English. So here you can download, click here, and you can download this file. It's N95 document. Here you have the Spanish version if you want to follow. And at the same time, I'm going to put here this work document of middle translate of Spanish and English. Okay. Nice. So next thing we're going to see next day. We'll continue with the Unification, we see the unification. Variables, we talk about variables. This, I'm going to translate this part. If we were talking about, we already talked about that, this part of induction and variables, scope of variables. It's a very important part. We told that. I'm going to translate that. And this part is interesting also. I'm gonna give you for the next day. Next day we're going to talk about that. This horn close, or cláusulas de Horn in Spanish. In English, I don't know exactly the term of cláusula. It's a logic term. We are going to use a subset of logic, because we can express only one subset of what type of rules. We're gonna explain next day. Next day we're going to start with this type of subset of logic. I hope I can have this translate for you for the next day, so it will be more easy if you after you can read the document and try to understand better. Okay, perfect. So let's go to finish today. What do you think? It's good for you, some minutes before, but I think it's enough for today. We have one of the most important concepts we are going to see is induction. So that is very important. If you want to work a little bit more, please try to read again, understand induction. And we're going to use every day this concept to resolve exercises. So this is one of the main concept. The concept of variable is very important too. The scope of variables. This idea of mathematical variables and classic computer science variables are also very important. So try to think about that. We can continue next Monday. And for not for this week, but for next week's probably I will give you at the end of the classroom some exercises to try to resolve, and we will use the Wednesday hour to, if you have some questions, try to resolve that exercises. Okay, because I told you before, usually we have 2 sessions a week. But for this problem with the, I don't know why the information is not clear. Last year's happened the same. I'm not going to change. So I want to use this Wednesday classroom to resolve questions, okay? So if you can.
At which hour it is on Wednesday?
Wednesday is, yeah, it's from 12:30
okay.
to 14:30.
Okay.
12 to 14, 12:30, okay? But this week, forget about this day because we have not enough knowledge to start to resolve exercises. Deal with more in the next weeks, okay? I will tell you when, okay? This Wednesday, if you want, if you have time, you have some lessons these days? At this hour, Wednesday at 12:30, you have another subject or not?
Yes, I do.
I too.
These 2 hours, or you have some space of time without subject?
Just 30 minutes for me.
Just for 40 minutes?
30, yeah.
30 minutes. Okay, will be good. 30 minutes. If someone have only 30 minutes, we can connect only this in this time. Okay, will be enough. 30 minutes.
Will it also be recorded? Because I have lessons and I have to work and
I can record again. Okay, yes, I can record this resolve. I can resolve and upload to Google. to YouTube.
Okay, thank you. Great.
Nice. Have a nice week and see you next Monday. Enjoy your time. Go to the beach to true surf. Bye. See you. Have a nice week.
Thank you.
Bye.
Thank you.
Bye.
Bye.
Thank you. Bye.